Might Proxima B at any point be another Earth-like planet? These are theories everybody continues to make in the quest for an habitable planet and extraterrestrial life on different planets. It's a thing that entrances people. There have been different hypotheses, and the way that signals have been recognized coming from Proxima B causes individuals to accept there is more to it. Regardless of this large number of signs, we still can't seem to decide whether these are messages from the planet or simply repeats of our own signals. Frequently, these signs end up as reverberations. To see if these signs are really from Proxima B, researchers desire to determine whether extraterrestrial life exists. As of late, the James Webb Telescope distinguished artificial lights on Proxima B. Assuming you're keen on finding out about different planets and our progress in tracking down extraterrestrial life, subscribe to our channel. We make content about space and examine developments in science. If you like this content, comment below and share this video with your companions. Now, we should dive back into our video. Proxima Centauri, around 4.2 light-years from our solar system, is a weak small star classified as GZ. This star is known as Proxima Centauri and is the closest to our Sun and planetary system. It was named Alpha Centauri by Johann Bayer in 1603. The name came from the stars rising around noon. While several heavenly bodies like the Moon and the Sun are in a systematic arrangement, Proxima Centauri is otherwise called Alpha Centauri or Alpha Centauri A. It is a solitary star system with 4 main stars in alignment, with Proxima Centauri at the center. Apart from the 4 stars, there are 2 weak smaller companions, Alpha Centauri B and Alpha Centauri C. These make up the heft of the mass but are too weak to be seen by the unaided eye. The system is found 23 degrees away from the line of the well-known Crux asterism in the constellation of Crux. Despite the fact that Proxima B is a rocky planet, there is still hope that it could have extra-Earth-like life. The quest for any life out there has brought researchers to Proxima B. They believe the similarities in size to Earth and the distance from its small star make it a feasible option for supporting life. While all of these are theories, there's hope that there may be some truth. There is a lot to find out about Proxima B and the orbit it takes, so stay tuned and check out some of our other content related to extraterrestrials. Do you truly believe there's other life out there? Leave a comment down below. What entrances a great many people about Proxima B is its similarity to Earth. Studies show that Proxima B is an exoplanet that circles an M-type star. Its mass is viewed as 1.27 times that of Earth, and it requires 11.5 days to complete an orbit around its star. Found in 2016, many researchers are investigating it. Despite the fact that Proxima B seems like Earth, specific features make it dreadful. For one, the planet is excessively close to its star, resulting in outrageous ultraviolet radiation. It is assessed that this radiation is many times more intense than what we get from the Sun. The radiation is so strong that it strips away even the lightest hydrogen atoms, and over time, it does likewise to oxygen and nitrogen. While many contend that Proxima B ought to be habitable because it is at a comparable distance from its star as Earth is from the Sun, there is something else entirely to consider. Distance doesn't account for whether there is water on the planet, and there is no proof of an atmosphere suitable for living things. The atmosphere on Earth makes it livable, not at all like Mars. A breathable atmosphere is fundamental for environmental regulation and a water-accommodating surface. It also protects living organisms from the dangers of space weather. If you're with us up until this point and haven't subscribed, please take a moment to hit the subscribe button. It makes it easier for us to keep creating content that you'll love. Now, let's see why people think the James Webb Telescope will assist us with figuring out whether or not there is life on Proxima B. Launched in 2018 after several delays, the James Webb Telescope was intended to observe infrared light. If a planet like Proxima B can absorb light from its star, it could also emit that light as infrared. The James Webb Telescope can take photographs of this light on the surface of a planet and search for patterns that could confirm whether the planet has water or an atmosphere. One reason space telescopes are preferred over ground-based ones is that they are above the atmosphere, allowing for clearer views of deep space without obstruction from moving air. Changes on Earth don't affect them, ensuring a consistent reading. However, fixing a space telescope is costly. If something goes wrong, it often requires an expensive mission to fix it. Since the James Webb Telescope is over 1.5 million kilometers away, salvage missions are not an option. The James Webb Telescope has a larger mirror, enabling us to see back to the beginning of the universe, almost 13.7 billion years ago. The further away an object is, the further back in time we can see it, as it takes time for light to travel from that object to us. The ability to observe the universe in longer wavelengths of infrared light allows us to see distant worlds with greater certainty than ever before, making the investigation of planets like Proxima B easier. Researchers Tabor and Curve have developed a scale of artificial illumination, comparing how the sun illuminates and compares to the day side of the planet. At 0% on the scale, the night side of the planet would be completely dark, while at 100%, the night side would be as bright as the day side. Theoretically, if there were a civilization on Proxima B utilizing artificial light, most researchers believe it would resemble early Earth. Studies suggest that if the night side of Proxima B reaches a brightness of 5% of the regular day side, the James Webb Telescope could detect the artificial light by 85%. If the brightness reached 9%, the telescope could detect up to 95%. Although 5% brightness sounds small, it is significant given the distance from Proxima Centauri compared to our Sun, which is multiple times dimmer. This means that at 0.1% brightness, we are still reflecting some celestial light. In other words, if Proxima B has a civilization glowing like Earth, the James Webb Telescope probably won't detect it unless the stars were multiple times brighter, a highly unlikely scenario given Proxima B's close orbit to its host star. It is possible that Proxima B may be tidally locked, meaning one side always faces the star while the other remains in eternal night. A civilization on such a planet could have to focus on illuminating their environment and using bright orbital mirrors to reflect sunlight from the day side to the night side. All of these are hypotheses made by Tabor and Curve, and there is yet to be confirmation to show that they are valid. Earth's illumination can be seen from outer space and is known as airglow. Many can't help but wonder why the Earth is surrounded by brilliant shades of red, yellow, green, and purple light when viewed from 300 miles above its surface. Airglow occurs when particles and atoms in the upper atmosphere produce light to release excess energy, like auroras driven by high-energy particles from the solar wind. Airglow is impacted daily by solar radiation. Since the James Webb Telescope's launch, researchers have been determining if it is sufficient to see different planets in distant systems. Despite being the furthest satellite telescope launched, it still provides limited information necessary to find planets with life in different systems. This has led to discussions about developing larger and better telescopes. Such endeavors are often costly and involve experimentation. The James Webb Space Telescope launch was 5 years late due to these issues. Therefore, it is challenging for researchers to develop better technologies for future launches. Regardless of this, the James Webb Space Telescope results are promising. Soon, we could know if there is life on Proxima B and other planets. While work is progressing for additional telescopes, the completion and launch of the Habitable Exoplanet Observatory, HabEx, is expected to revolutionize space exploration. The estimated completion time for HabEx is 2035, with a launch shortly after. HabEx will be sensitive to all planets in the universe and primarily aims to search for Earth-like planets. Its cutting-edge technology will enable it to measure the spectra of most planets and determine their habitability. HabEx is also expected to have a wide range of astrophysical capabilities, enabling it to study the earliest times in the universe's history and understand the life cycles and deaths of massive stars, as well as the processes that support life as we know it. Although still in development, the technology behind HabEx will allow it to concentrate on Earth-like planets at an incredible resolution, providing extraordinarily clear images. Bright close to infrared and optical photons, the idea driving HabEx is convincing and could change space study fundamentally. If effectively carried out, it will empower more in-depth investigation of extraterrestrial life on different planets and offer a better understanding of Earth's history, including environmental changes before human civilization. The Laois thought addresses a smaller version of a telescope, however, it expands on the experiences gained from the James Webb Space Telescope. It has bright capabilities and is considered the next observatory telescope to be widely used by cosmologists. Plans to launch Laois simultaneously with HabEx are in progress. The large UV optical Earth surveyor Laois will greatly enhance space studies. With Laois, it is proposed that it will help understand what makes Earth particular. Observations of 28 Earth-like planets have produced promising outcomes with the advancements in intel, extensions, and the insights concerning planets like Proxima B. Observability can improve fundamentally, despite the fact that the James Webb Space Telescope has made great strides in uncovering new insights regarding Proxima B. There is still a lot to be improved. Observability and the capacity to analyze environments differently are fundamental to determining whether extraterrestrial life exists. This also provides profound insights into the planet's history and the changes that have happened over the years. Ever wondered what might occur if we found extraterrestrial life? Fear not, we have videos on our channel discussing this and more. Subscribe and hit the bell button to get notified whenever we post new content. Is there life beyond planet Earth? The discussion about existence on different planets has been ongoing for quite a while. Most individuals believe that we are not alone in the universe. Different hypotheses and claims have endured over the years. Whether we find life on different planets depends largely on the research we conduct. For this reason, researchers are working on ensuring more powerful space telescopes orbiting the Earth and other planets. However, these telescopes need to go beyond infrared lighting to provide improved answers regarding various planetary life. For now, we watch with bated breath as we hope to see if our sibling planet Proxima B has any life on it. If you love content like this and want to learn more about the James Webb Space Telescope and Proxima B, make sure to stay tuned. Proxima B's location in the habitable zone of its star raises intriguing possibilities. This zone, often referred to as the Goldilocks zone, is where conditions may be perfect for liquid water to exist, neither too hot nor too cold. That Proxima B could harbor water, regardless of its challenging environment, is a focal point for researchers. Water is considered essential for life as we know it, so understanding its potential presence on Proxima B is crucial. Recently, the advent of new technologies has allowed space experts to better analyze exoplanets. For instance, spectrometry, a process used to determine the composition of light from distant objects, can provide insights into a planet's atmosphere. By studying the light spectra, researchers can identify the presence of gases like oxygen, methane, and carbon dioxide, which are indicators of potential biological processes. The novel characteristics of Proxima B also pique the interest of astrobiologists. Its proximity to Proxima Centauri, an M-type star, results in different celestial dynamics compared to planets orbiting G-type stars like our Sun. M-type stars are known for their frequent flares, which can bathe nearby planets in radiation. Understanding how Proxima B's atmosphere interacts with such celestial phenomena is vital for assessing its habitability. Another aspect of Proxima B that catches attention is its orbital elements. If Proxima B is indeed tidally locked, it would result in extreme temperature variations between its day and night sides. This could lead to unique weather conditions and perhaps even diverse ecological zones. For instance, the day side might be too hot for life as we know it, while the night side could develop a more temperate environment where life could thrive. Scientists are also considering the potential for extremophiles, organisms that can survive in extreme conditions, on Proxima B. If life exists there, it may not resemble Earth's life forms. Instead, it could be akin to extremophiles found in Earth's most inhospitable environments, such as deep-sea hydrothermal vents or acidic lakes. These life forms adapt to extreme heat, pressure, or acidity, suggesting that life could manage to exist under Proxima B's harsh conditions. Investigation of Proxima B's atmosphere is a key objective for upcoming missions. Future telescopes, like the European Space Agency's Ariel mission, are expected to focus on the atmospheres of various exoplanets, including those in the vicinity of Proxima Centauri. Ariel plans to explore the composition, structure, and dynamics of exoplanetary atmospheres, potentially shedding light on the conditions that could support life. The search for biosignatures, signs of past or present life, remains a top priority. Researchers are particularly keen on identifying chemicals that could indicate biological activity. For instance, the simultaneous presence of methane and oxygen in an atmosphere could suggest biological processes at work, as these gases tend to react with one another and wouldn't normally coexist in significant amounts without ongoing replenishment. In addition to the scientific endeavors, public interest in the quest for life beyond Earth has never been higher. Documentaries, books, and online content have fueled curiosity about the universe and our place within it. Consequently, the pursuit of knowledge about Proxima B and other exoplanets has become a cultural phenomenon, inspiring a new generation of scientists, engineers, and enthusiasts. Moreover, global collaboration has become increasingly important in this field. Countries across the globe are pooling resources and knowledge to develop advanced technologies for exploring distant worlds. This collaborative spirit is essential for addressing the complex challenges that arise in space exploration. Proxima B also serves as a test case for how we approach planetary protection. The protocols established to prevent contamination of other worlds must be carefully considered as we send missions to study potentially habitable exoplanets. Ensuring that we do not introduce Earth-based organisms to these conditions is vital for preserving their integrity. As we continue to push the boundaries of our understanding, Proxima B remains a tantalizing target in the quest for extraterrestrial life. Each new discovery brings us closer to answering one of humanity's most profound questions: are we alone in the universe?